begin our course now. So last week we have, sorry, that's my laptop. Last week we have introduced something about the control structure, which is if-else statement, right? Examples like this, and given a student's grade, and then the system, we say the program should output the letters for the grades. Like if student's grade is over 90, it should be A. If the student grade is over 80, it's supposed to be B. And we almost stop there. And let's review some more slides. And then here, we also introduce some concepts about the blocks in the if-else statement, like everything in between curly brackets, we say it is a block, right? Statements contained in a pair of braces, such as the body of the method, we say it's a block. And a block can be placed anywhere in a method that a single statement can be placed. Like here, it is only one individual statement. However, in the else block, we have two. And then here, for the if-else statement, we also have some syntax errors that's like a missing brace or a logic error, like when both braces in the block are left out of the program, or a fatal logic error, like it causes a program to fail and terminated prematurely, and maybe a non-fatal logic error that allows a program to continue executing, but cause it to produce incorrect results. That's some syntax errors. Okay, then today we are going to introduce something more. Like in the if-else statement, we can use the conditional operators, which we say is a question mark with a column. It is a pretty frequently used symbol with an operator in our program, especially when if you are practicing some VCode code. Using the conditional operators can make you to simplify your lines of codes. And the conditional operator, it is a shorthand for the if-else. It is, we also call it a ternary operators because it takes three operands. And the operand and the question mark with column formed a conditional expression. The operand to the left of the question mark is a Boolean expression, which evaluates a Boolean value. That means in this example here, students grade over 80. This is a Boolean expression, and the answer for this expression is supposed to be only two possible candidates. The first is true, the other one is false. If student's grade is over 60, it means this Boolean expression is true, otherwise it is false. And the second operand between the question mark and the column is the value if its Boolean expression is true. That means this one passed. Okay, I will mark it using green. That means how can we understand this line of code? If student grade over 60, if this is true, and then we print, here is the system output, we print passed. Otherwise, if student grade is smaller than 60, we print out fail. This is how we can use the tertiary operators. And third one here, to the right of the column is a value if the Boolean expression evaluates to first. Okay, and then I will write a demo code for that. Here we say we new a Java program file. Okay, for those who are not familiar with how to code, so each time I code by myself, so you may practice follow the video, follow the recordings after me. Then we give it a name to this class. We say test the conditional operator. Okay, then we have a class here now. Then we input PSVN, create the main method so it can run. If the class without main method, it cannot run. So here we declare a integer, or we say a double, which is a float number for the student grade. And we initial this variable to be like 78 here. And then we using the same example from the slides. We say we solve something here. Student grade over 60. If it is true, we print out passed, and we write the column here. And if the Boolean expression is false, we print out fail. So let's run the code and see the output. Okay, see, here it indicates that passed. If I change this to 58, this program, let's run it again. And let's check. Okay, it now becomes fail. So that is how the conditional operator working in our program. And after that, we will write a more complex program to demonstrate the if-else statement, which is listed in the textbook in the figure 4.4. This is the code. And for the class students, it stores a student's name and average. I think this is the average score for the student. And it provides the method for manipulate these values. So like this one give us some hints. We have some instance variables. One is the name. It's supposed to be string to store a student's name. Okay. Let's first create such kind of class. You say student. Sorry. As it has some indications. So here it is the instance variables. We say it indicates attributes, right? So what instance variables are we going to have? It says instance variables name of type string. So we should declare an instance variable. The type is string and the variable name is name. And then let's see the second line, the instance variable average of type double to store a student's average in a course. Okay, fine. Just follow the instruction. Double average, right? Pretty simple. I think it's supposed to be a lowercase. And then the third line, a constructor that initializes the name and average. So let's declare a constructor. So let's recall what's the function for constructor. It is used for initializing the instance variables when creating a construct instance object. So how can we declare a constructor? We say that the constructor always has the same name with the class name, right? So it's supposed to be public void student. As it says that the constructor is going to initialize the name and the average. So we should pass two parameters to the constructor. One is the name, the other one is the average. So for the name, it's supposed to be a type of string. And then for the average, it's supposed to be the double. And then we use curly brackets to initialize it. So currently, we don't have any other conditions to implement because it doesn't give us any hints. So what we'll do is just using the this dot name is equal to name. And this dot average is equal to average. So that's done with this per the instruction. And then we will have some methods like set name, set average, and get average to set and get the student's average. So let's try getter and setter methods. So for the set name, since if we are going to set the name, so we need to provide the program the name we want to set, but we do not expect the program give us something. So we should declare it's a public void method. You say set name, right? And then what we should pass is string name. Okay, here I made a typo. Public void. And you say this name is equal to name. And same thing for the average. Okay, we have done with the setter method. Then let's complete the getter method. Okay, for the getter, we are going to get the average. Since the average is a certain kind of variables in the double type, which is provided by the program, so we should set the return type of the get method. So that is the double. And then we write the method name average. Since we do not request to, since we are requesting something from the method rather than providing something, so we do not pass any parameters to the get method. Here, what we need is just ask the program return as something. As we say, return the average. Okay, also the name, sorry. We do the same thing for name. Public string get name, and then we say return the name. All right, almost done. So he also asked us we should write a method of get letter grade, which use the nested if else statement to determine the student's letter grade based on the student's average. So let's say public, we should provide something to the users, right? So the string is supposed to return the string type because it is a letter grade. supposed to be the A, B, C, something. So here, the method name is get letter grade. So in the get letter grade, okay, let's go to the here. It is the standard set by the textbook. We say, okay, firstly, we should initialize the string letter grade. You can initialize to be empty or you can leave it nothing. Letter grade. And the standard is if it is above 90, we set the letter grade to be A. Okay, let's see. Let's try. If the average is above 90, above and equal to, and then we set the letter grade to be A, right? And else if average, sorry, I want to copy so that it might be faster. Over 80, and then we set it to be B. Right? And else if, okay, let's copy the whole thing. If it is 70, okay, we say it's supposed to be C. 60, it is D. And the other one is else without as if. Okay, this is the default else, and which is the last one that is false. And then we should return the letter grade. So that is the nested if else statement here. And what we are going to do is then create a test method, like we say in this picture. We create a test class, student, test, right? So here I create the main method, ESVM. Only when I have the main method, I can run the program. So here's, I create the first instance, which is account 1, right? Which is new student. And then what we are going to pass is to set the name as Jane Green. And we set the variable, the average is supposed to be 93.5. We don't create two instances. Okay, let me see first. Why there is some problem. Expect no arguments but font 2. Student. Here is the student. Our constructor is requesting two parameter. So let me debug it. Student. What's the problem? Let me get back to this one. Public, I see. Here, for the constructor, I should not include the void. It's a typo, it's a typo. So here we figure out the first problem, and then let's get back. Now, this is working now. So let's go to the test method here, and then let's output something. Okay, since we are formatting it, we are using system.output printf format. So we're using the placeholder, which is the percentage s, which is that is going to be replaced by the account1 dot get name. So we can try here. What is the percentage s output? Okay, sorry. Yeah, supposed to run this one. So Jane Drain. That means this placeholder is replaced by the account name one get method, which returns the Jane Drain to here, to this placeholder. And then let's type something. Letter grade is, okay, another S, and change a new line. So we have two placeholders now. The second one is supposed to be the account1 dot get letter grade. So let's run it again to see the output. So Jane Drain's letter grade is converted to A. Let me remove this space. Okay, here I write one terminal here, and then it output in the second line. Actually, I don't need it because I changed the line already. So I put it here. Let's see the effect. Okay, great. So the 93.5 is converted to the letter grade A. What if I set it to the 72.75? Okay, let's see what's the output. Now, the 72.75 cents is converted to the letter grade C. And that is the create and attach student objects. Let's get back. Here, let's go through the slides that the constructor and the method setAverage each use nested if. This line refers to this block of code here. To validate the value used to set the average. These statements ensure that the value is greater than 0.0 and less than or equal to 100%, 100.0. Otherwise, the average value is left unchanged. Okay, this one. So that means here for the set average, we are going to have a condition that if the average, right, should be greater than 0 and less or equal to 100%. Otherwise, the average value is left unchanged. So we can say if the average is bigger than 0.0, and we use a nested if statement lower or equal to 100.0, this is a nested nested if statement. Average. But it says that this is supposed to be in the constructor. So I put it into a wrong place, and then I should move it to the constructor here. Okay, fine now. And each if statement contains a simple condition. If the condition in line 3 is true only, then will the condition in line 14 be tested? And only, let's see, what is 14, 17? Oh, here. If average is bigger than 0 and nested with the if average is smaller than 100, and we assign to the instance variable. Otherwise, we left it unchanged. That is the constructor. Okay, we have covered this one. Then this is for the if-else statement. Okay, I will close it. And the other control block is the while iteration statement. The iteration statement means that this line of code or this block of code, we say they repeats an action while a condition remains true. The pseudocode is while there are more items on my shopping list, purchase next item and cross it off my list. The iteration statement's body may be a single statement or a block. So eventually the condition will become false. At this point, the iteration will terminate and the first statement of the iteration statement executes. Okay, let's see here this example. Like, find the first power of 3 larger than 100. Assume the int variable produced is initialized to be 3. And this is the while iteration statement. So for you to better understand this example, let me create another class to visualize it. So here is the hence while iteration. And then we create a main method, PSVN. Then we declare the product, double, product. And once we declare it, we can use it. So we put it in the while statement. While something product is smaller than 100. And then the product is equal to 3 multiplied by the product. What's the problem with that? I think it's because we don't initialize it. So here it says, assume an int variable product. Okay, sorry, it's an int. And it's supposed to be 3. So it's fine now. Let's output to visualize it. So current, we say current product is product. Okay, let's see how it works. So go. Okay, fine. This is the output, the while iteration. Before the while iteration, the product is 3. And then the code proceeding to this one. While product minus 100. currently, since 3 is smaller than 100, so the program will execute the contents, the codes inside this block. And then the products will become 9 here. And once it becomes 9, we have user output here, and then it becomes 9, right? And it will go back to line 5. Now in line 5, we are going back to here. So 9 is still smaller than 100. So we iterate the while loop again and again until here, current product is 243. So there is a condition here. The product is currently is 243, right? So 243 is over 100. So in this case, the while product smaller than 100 is no longer valid. So we stop executing this block of codes, and then we end this program. And we can say, so program ended. Let's see. Now program ended. That is the while iteration statement. Here it says each iteration, the multipliers produce product by 3. So product takes on the value 9, 27, 81, and 243 successfully. When product becomes 243, the product minus or equal to 100 becomes false. We say this here. This Boolean expression here becomes false. So the iteration terminates, and the final value for the product is 243. So the program execution continues with the next statement after while statement, which is this one, the output, the system prompt output the program ended. That is for the while iteration. And for the UML activity, okay, let's go to the UML activity directly. Here, it is the starting point. The black dot is the starting point of the program. And then it go to the first diamond, empty diamond here, that to make the merge decision. If something like the product, if it is smaller than 100, right? And then it will go to the right-hand side and triple product value. And then it will go back to the first diamond, empty diamond, and to merge everything, and then go to the decision again until the product is over 100, and then the program terminates. So here it is a formally explanation for the UML drawing that the decision and merge symbols can be distinguished by the number of the incoming and outgoing transition arrows. A decision symbol has one transition arrow pointing to the diamond and 2 or more pointing out from it to indicate possible transitions from that point. So each transition arrow pointing out of a decision symbol has a guarded condition next to it. A merge symbol with the first one. The first one is merge. The second one is decision. Okay. So the first one, which is the merge symbol, has 2 or more transition arrows pointing to the diamond and only one pointing from the diamond. This is to indicate multiple activity flows merging to continue the activity. None of the transition arrows associated with a merge symbol as a guardian condition. So for the merge, we don't have condition. only when we are make our decision, and then we have the branches there. And then let's consider another scenario. We are going to using a counter-controlled iteration. What does it mean, counter-control? That means we have using a counter to control the iteration loops, the times we are going to iterate. Suppose that a class of 10 students took a quiz. The grades, like the integer in the range from 0 to 100, for this quiz are available to you. Determine the class average on the quiz. So here we are going to determine the class average rather than the student's average. And the class average is equal to the sum of the grades divided by the number of students. Okay, it's trivial. And the algorithm for solving this problem on a computer must input each grade, right? So we have to keep track of the total of all grades input, perform the average calculation, and printing the result. That means we should have something to indicate how many students we already get their grades. Like if I input 5, so the program should have a variable to indicate that, oh, 5 students get inputted, and the next one is a 6. So let's consider from the pseudocode. So here we say that we use a counter-controlled iteration to input the grades at one at a time. A variable called a counter or control variable controls the number of times of a set of statements well executed. And this one is often called definite iteration because the number of iteration is known before the loop begins and executing. Here we say we have 10 students, so the counter is supposed to be the maximum 10. Except for the counter, we also need a total variable that is used to accumulate the sum of the several values. Like we have using a total variable to indicate that the aggregation of the whole class students' grades. And a counter variable is used to count. So in this case, the average grade for this class is the total divided by the counter, right? It is pretty trivial. So this is the pseudocode that we used for our program. First, we set the total to 0, and then we set the counter to 1, because the counter should indicate how many students already get inputted. So while the grade counter is less than or equal to 10, we do the following block of things. First, we prompt the user to enter the next grade, and then we input the next grade. After that, we add the grade into the total, and then we add 1 to the grade counter, indicate that, oh, we already have one more student's grades, and then we requiring the next one. After that, we set the class average to the total divided by the counter. Okay, here it's pretty straightforward. It says by 10. And then we print the class average. So here is our code. We can write it by ourselves. So keep practicing. Sometimes, although it is like we copy every line of code from the slides, but as long as you input it by yourself, you will become more and more familiar with it. So let's try. So then we create a new Java class named class average here, right? Follow the same thing with the slide. And then we create our main method, PSVM. After that, we use a scanner to obtain the input from the command window. Here we use the scanner input, and we new the scanner object. Yeah, system .in. And the system the first S should be capitalized. And we use the semicolon to end this line of code. After that, we initialize the total. This is indicating the accumulation of the whole grades of the class. And then we use the grade counter to indicate the counter variable. And it's supposed to be initiated by 1 because students are started from 1 rather by 0. 1, 2, 3, 4 until 10. That is the counter. So while counter, grade counter is more and equal to 10, that means currently how many students we have counted. Okay, we have a system prompt that indicating enter the grades. Okay, plus, no, we haven't fetched the value. So here we're declaring a new variable grade to indicate the grades we input from the command line. Next int. Okay, here we can get another user prompt, that is the student grades you input. Yes. Okay, we use a double S here. Great. Okay, this is a comma. Okay, why it is error? It's supposed to be S. Okay, fine. And we say, let's say the number we use a %d as a placeholder to indicate the grade counter. So you will know currently how many students you have already get inputted. Then we can try now. We don't need to complete the whole program at one time. We can do it one by one. Like currently, please enter the grade 60. Okay, it outputs something. Well, S. The grade is S. So here I still need to make it as D. So sorry for that. Let me try again. So enter the grade 60. Okay, the first one student grade you input is 60. And I think I should using a new line, right, to separate them. And I should using a spot to terminate this line of code. So let's try again. Writing code is making mistakes and debug and continue. And making mistakes, okay, debug and continue. Kinds of boring things. Okay, fine. Let's see. The first student grade you input is 80, and we enter the next one, 90. Okay, here it still indicates the first one, right? So we are missing something because we didn't increase the grade counter. So here we say grade counter is equal to grade counter plus. Okay, let's try again. The first one is 80. Okay, the second one is 50. It's still not good. Greater is 1. Grade counter. I think it's supposed to be correct. This one, this one, this one. Okay, it's now correctly going. I still don't understand why using the double 2 plus symbol is not working. Maybe because I don't know, but it's fine. I using the +1 explicitly, and then now it's working. Maybe I'll check after this course. So here we are successfully setting the program to get input from the user prompt to fetch 2 students' number and output the prompt indicating the students' grades. And what we'll do is then we should add the students' grades to the total. Total is equal to total plus the grade each time we get input from the user prompt. And then we will declare another variable that is the average that is equal to total divided by the, oh no, this is only happened after we fetched 10 students' grades. So this line of code which takes the average should out of the while block. After that, you sort out the average for the class is average. Okay, it has problem again. Let me change it to S. Fine now. All right. So let me try this program. Okay, for the first student, we said it's 90, second, 80, third, fourth, fifth, 7, 9, 10. Okay, it output the average for the class is 57. Okay, it's let me count whether they take 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, done. This program runs successfully. And I think it's almost the same thing. Yeah. It is divided by 10, but in my code, I'm using the grade counter instead of the 10. That they are the same thing. And this is the example input and output. Okay, fine. So here in the counter controlled iterations here in the main, we have to introduce something about the local variables in the main method. Variables declared in a method body are local variables. We say here the grade as a local variable because it can only use from the line of their declaration to the closing right brace of the method declaration here. That means the grade is only valid from the line 12 to the line 16 because it is the grade is wrapped between the while statement block, as it is a local variable, and a local variable's declaration must appear before the variable is used in that method. So here, the grade we declared here, but we used after its declaration that appears into the next line of code and the next line here. A local variable cannot be accessed outside the method in which it is declared. That means outside of the while loop, the grade is no longer valid. So we can test it. Suppose we don't take 10 students, we take 2 students. And then here we say sort. We print the grade again to see what it happened with our program. Okay, here as you can see, before I executing it, the program throw me a error that indicates that for the class average.java class, it cannot resolve symbol grade because it is a local variable only valid in the while method, which is from the line 10 to line 60. Out of this scope, the grade is no longer valid. But what about the grade counter? Right? The grade counter is still no problem because it is wrapped between the main method here. What if I initiate the grade counter inside while loop? Let's have a look. Okay, now, since I initiate the grade counter in the while loop, and the Boolean expression here is going problematic, right? Here, it says cannot resolve symbol grade counter. That means you can only initiate a variable before its use. So we should put it before the line 9. And that's what. And also there are some notes on integer division and truncation. The program's output indicate that the sum of the grade value in the sample execution is 846. This is this example, right? But it outputs the class average is 84. And it's supposed to be 87. No, 84.6, but it only indicates it discarded the point 6, the tail, the decimal point precision for the class average. Why? Okay, that is because for the total over the average, it is a decimal point value. However, we assign that value, the average, to a integer placeholder, and the integer placeholder will only take the whole number part and discard the decimal point tail. So that is the reason for the arithmetic overflow. For the division and truncation. Here it says the result of the calculation total over 10 is the integer 84 because the total and the 10 are both integers. Dividing 2 integers result in integer division. Any fraction part of the calculation is truncated. We say the precision that the decimal floating point tail. Okay, here, for the total equals to total plus grade, this line of code, even this simple statement has a potential problem, like adding these integers could result in a value that is too large to store in an int variable. That is known as the arithmetic overflow and can cause undefined behavior, which can lead to unintended results. Like you may input someone's grade wrongly by indicating 999999999, like 12 digits of 9, and that will incur the arithmetic overflow problem. Same issue is for the number 1 plus number 2. Okay, we don't do that. Let's have a look over his code. Okay, this code doesn't have the number 1 plus number 2. I think it's a new created cases. That means 2 integers plus together. And here, one thing we have to know is that the maximum and the minimum value that can be stored in an integer variable, we can replace them by the constant min value and the max value, respectively, which can be defined in the class integer. So we can have a try. Okay, here is some problem. Okay, this is the comment. You create the min max ESVN. Okay, let's solve the min value. Can we do that? Yes. Okay, import static constant. Okay, long. So let's output it. Okay, it says the min value is minus 922337. Okay, it's fine. I don't care what it is. I just want to show you that such a thing can be stored in an int variable and are represented by the constant by min value. You can use this directly. So let's have a deeper look at the receiving user input here. For our student grades, class average example here. At any time a program receives an input from that user, various programs might occur. For example, in the following statement, we assume the user will enter an integer grade that in the range 0 to 100. However, the person enter a grade could enter an integer less than 0. So what could it be happen? Let's try. Like if I input minus 12, okay, it's still there. That means the student's grade you input is minus 12. That means the error is not fixing. And the program doesn't throw any hint and just keep the wrong numbers there. What should we do here? So to ensure that inputs are valid, industrial strings programs must test for all possible erroneous cases. A program that inputs grades should validate the grades by using range checking to ensure that they are the values from 0 to 100. And you can ask the users to re-enter any values that is out of range. If a program requires input from specific set of value, you can ensure that each input matches the value in the set. That means when we are getting some inputs here, right? So we should write a range check. We say if greater it's smaller than 0.0, output. So input is wrong. And it's supposed to be a positive number. Except for the checking for -0, we also have to check it whether it is over 100. Because the grades usually between 0 and 100, right? So input is 1, it's supposed to less than 100. So in this case, if the user inputs a wrong number, we can get the warnings immediately. Let's try. So here, enter the grades. We say -12. And then it says your input is 1, and it's supposed to be a positive number. And what if I enter 105? It says your input is 1 and it's supposed to less than 100. So that's for the range check. Except for the range check, there are several things we should also get informed. One thing is about the Sentinel controlled iteration. That means we develop a class averaging program that processes the grades for an arbitrary number of students each time it is 1. And the Sentinel controlled iteration, we also call it indefinite iteration because the number of iterations is not known before the loop begins executing. And for the Sentinel, that means a special value is called a Sentinel value, right? We also call it a signal value, a dummy value, or a flag value that can be used to indicate end of data entry. And a Sentinel value must be chosen that cannot be confused with an acceptable input value. Usually, in industry, we say such a value could be like -1 or a 0 or a special symbol. So let's take a look over the slides how it used. So for the Sentinel controlled iteration, let's first define the pseudocode for that. We are going to design a pseudocode algorithm with top-down method stepwise refinement. And the top and the first refinement is followed as the steps as first. It begins with the pseudocode representation of the top, a single statement that conveys the overall function of the program, determine the class average for the quiz. And the top is completely representation of a program. It really conveys sufficient detail from which to write the Java program. Okay, let's go further. And divide the top into a series of small tasks and list there in the order in which they'll be performed. So the first refinement is, let's initialize the variables, import, sum, and count the quiz grades. And then we calculate it and print the class average. This refinement uses only the sequence structure, and the steps listed should execute in order, one after the other. And after the first refinement, we proceeded to the second refinement that commit to a specific variable. So for the pseudocode statement, we say we initialize variables, and then it can be refined as initialize total to 0, initialize counter to 0. And then we proceed to the pseudo statement, input some content quiz grades, and which requires iteration to successively input each grade. Okay, we don't know in advance how many grades we will be entered, so we will use a Sentinel controlled iteration. This is the whole view of the pseudocode. Also, it is looked a bit lengthy and verbose, but for the code itself, it's pretty easy to understand. Here we say, I will create another new class average. Class average Senti, right? Class average Sen. Okay, that is for this class. And we create our main method and we create our scanner. System.in. We declare the total is equal to 0. Int grade counter to be 0. And here is the thing. Since for the Sentinel, when we are using the top-down method, we don't know when the program is going to be end or when we should exit the program. Here we first give the user a prompt that, okay, here the Sentinel is set to be -1. So that means if you are enter the grade to be the -1, that is to quit. So let's formally begin fetch the grade from the command line. Grade equal to input dot next in. Here we say while grade is not equal to -1. That is the Sentinel, how it works. Loop until Sentinel value read from user. Here we add the total with grade. We didn't initialize the grade. Does it initialize? No. Oh, grade is here from the user input. And then we increase the grade counter. Right, we use double plus plus means self-incremental. And we repeat the prompt. Repeat. And then we using the grade to fetch the user input from the command line. So let's try. Okay, let's try it now. So currently 10, right? If I input -1, okay, the process finished with x equals 0. That means the sentinel, when I input -1, that means the program, the while loop is end. So the whole program is going to be ended. Let's write a user prompt. So program ended. Yeah. You can also say integrates. Oh. Okay, let's try. This time I want to input 3 students' grades. So the first student is 90. Although I don't have a specific number in the Boolean expression to indicate the grade counter, right? It doesn't appear and it doesn't count it in the Boolean expression. So I want to input 3 students. 90, 80, 70. Then I want to quit the program. I input -1, which is the sentinel we set in the while Boolean expression here. So once I input the -1 and the grade, only one grade is not equal to -1, it will count the grades into total. Otherwise, it will go directly to the line 22, indicating that the program ended. That is how the sentinel working in our program. And then we still have some more slides. Okay, let's finish these slides and then we can end our class today. So let's see what the slide is talking about. So for the explicit and implicit converting between parameter types, okay, we have already talking about it in our previous lectures, so we will skip it. And here it mentions some new things like the operator is a unary operator, an operator that takes only one operand. We call it a unary operator, which is this one. Grade counter ++, it only takes one operand, so it's a unary operator. Java supports unary versions of the plus and the minus operators. That's how it works in our programs. And for the next slide here, okay, here. For the floating point number precision, they are not usually 100% precise, but they have numerous applications. For example, when we speak of a normal body of temperature 98.6, we do not need to precisely to a large number of digits. So the floating point number often arise as a result of division, such as in this example class average calculation. We may have some floating point precision tails after the whole numbers. In conventional arithmetic, we divide 10 by 3 and the result is 3.333 something, with the sequence of 3's repeating infinitely. And the computer allocates only a fixed amount of space to hold such a value. So clearly, the stored floating point value can be only an approximation rather than precisely presented and stored in our memory. So owing to the imprecise nature of floating points numbers, the type double is preferred over type float. Although both of these two types referring to the decimal points numbers. But as you can see, when I was programming, I used double instead of float because double variables can present floating points numbers more accurately. And in some applications, the precision of float and double variables still will be inadequate. For example, precise floating point numbers, such as those required by monetary calculations, Java provides big decimal types, which we'll discuss in our chapter 8, to present those numbers with more precision than double type. And the following case study and examines the nesting one control statement within another. Suppose a college offers a course that prepares students for the state licensing exam for real estate brokers. Last year, 10 of the students who complete this course took the exam. The college wants to know how well its students did on that exam. You have been asked to write a program to summarize the results. And you have given a list of these 10 students. Next to each name is written a 1 if the students pass the exam or 2 if the students fail. And here is the pseudocode. And let's go to the real code directly. Here is the analysis. Here, in using the scanner to obtain the input from the command view, that means we can decide whether the students pass or fail, right? So here, but it also gives 3 instance variables here. One is pass, the other one is failures. The third one is student counters, like this is for calculating how many students we have counted until now, up to date. So while student counter is smaller than 10, that means we only count 10 students' grades here. So we read the result from the user input. If the result is 1, that means 1 more student passed the exams. Otherwise, that indicates the student has failed on the exams. After the decision, we increase the student counter because we already counted 1 student up to date. And here it will output the statistics, the breakdown for the students who pass, how many students passed and how many failed. If 8 students passed or over 8, the systems will prompt that, oh, there are some bonus to the instructors. However, there is no bonus to me, but it's fine. Okay, this is the demo example. I will not show it because it's a little bit similar to our prior examples. So we just have a look of it, have a notion of it, that's fine. And then we are going to introduce some compound assignment operators. Compound assignment operators abbreviate the assignment expressions. For example, for C equal to C plus 3, right? We can rewrite it in the additional pound assignment operator plus equal at C plus 3. We can try in our example here. We're using the first class average and we modify here the grade counter here, we modify it as plus equal, right? Okay, let's see whether it can output the correct numbers. So we are going to input 2 student grades. Okay, let's say the first is 100. Okay, great. The other student is 0, right? So there are some mistakes. That means the grade counter here increased by 2, 3. And let's take it as 0. So it will only increase 2 times. Okay, let's try again. 100, 0. No, it's not the correct way. Okay, we have to figure it out. 1 is here. If we are entering it, we are calculating it. And once we calculate it, we increase it. So that means, oh, here, that means in the outside, grade counter should -1 here. That is the correct way to run this code. So let's try. Enter the grades 100, 0. Okay, now it is now calculated correctly. The average for the class is 50. So that means using the plus equal is the same thing as we write in the C is equal to C plus 3. Here I use the compound assignment operator. 1 is to increase 1. The last one is to decrease 1. And there is some other assignment operators for plus, minus, multiply. This is the division. This is take the remainder. We say mode. They all can be used in compound assignment. And for the unary increment, plus plus and minus minus, they are the same thing. In the second example, or I think I use it, right? Where I use it? I forgot, but it's fine. Oh, here is the way I use the increment and increment operators. This is the unary increment operators, plus plus. That means add 1 to its operand. And if we are using the minus minus, it's the same thing. We subtract 1 from its operand. And there are some difference between the positions of the increment and the decrement. The prefix increment, that means the value of this operand increased by 1, and then we use the new value of the variable in the expression. If the plus plus is after the variable, that means we use the variable first. After we using that, and we increase it by 1. And the same thing for the decrease. And this is an example here. We say we can see that in line 7, we initiate and declare the variable C, and we assign 5 to C. The first line we print 5 because we only print C there. The second line we output the C++. However, it still prints 5 because for the post increment, we use the C first, and then after we use it, which is after the line 9 executed, we print 5 and the C increased it by 1. So in the line 10, even we don't increase the C has already changed to 6. However, in the downside, we use the prefix increment. That means we firstly increase the C in line 17. Now it outputs 6, and then we execute this line of code. After that, the C keeps the same. Okay, this is for the operators and their associated activities. For the double plus and double minus, they can be associated with the operand from the right to left or from the left to right. That means I can put the plus plus in the right of this operand, and I can also put it in the left. However, for the downside, plus and 1, it can only from the right to left. That means here, the plus can only be in the right of the total. That is the right to left. And also there are some other operators like the smaller, equal, bigger, equal. They are all left to right because we are reading it from the left to right. There are some they indicate the operands relationship. And for the equal and not equal, they are also the left to right associativity, indicating the different side operands equality. And this is the conditional operator, a question mark with a colon that is also left, right to left. And in our book, the appendix D lists the 8 primitive types in Java. And we say we always require the variables to have a type because only when we declare and initialize a variable, we can use it. Java is a strongly typed language. However, Python is not. And the primitive types in Java are portable across all platforms. Like no matter you run it in Windows or Mac, they are the same thing. They are no different. And instance variables are some types of the char, byte, short, int, long, float, and double. They are all given the value 0 by default. And the instance variables of type Boolean are given the value false because we say 0 indicates the false. And for the reference instance, we are initialize them by default to use the value null. And okay, that is for today's course. And just around the point. Okay, if you have questions, you can stay. And otherwise, you are free to go now. And next week, we will have our lab session. We will have a lot of lab in the future because practice makes you perfect. And then good night. Thank you.
Have a great one, Professor.
Okay, thank you.
Good night.
Good night.